Hello everybody, welcome to my channel Programming in C with RSK, and I am Rajendra Kulkarni. Friends, in this video we are going to see how array of string pointers is declared, defined and used, and also how dynamic memory allocation is made in C. So let us start with our presentation. This slide shows how the available memory of 1 MB is divided into 4 segments. Please note, this 1 MB memory is directly accessible by C programs, and hence we say that only 1 MB memory is available for our programs. This 1 MB memory is divided into 4 segments. The segment of having address starting from 000H and goes on with 64 kilobytes is a code segment. All these addresses which are shown here are in hexadecimal number systems. Code segment contains the compiled code of our program which needs to be in the memory for its execution. The next segment of 64 kilobytes is a data segment. It is used for storing the data created by the program and the data which will be useful, which will be used by the program in its execution. The third segment of 64 kilobytes is a stack segment. It is a last in first out segment stack, LIFO stack, and there is a extra segment of 64 kilobytes. When a function is created by the programmer, all the variables declared and defined in that function are stored in the locations on stack segment. So the stack segment or the stack is a place where all variables of a function reside. Then there is a data segment. In this segment, the data which is created by the program and also the data which programmer wants to store during the execution of the program is available. So these 3 segments are mainly used by our small programs: code segment, data segment and stack segment. When control of the program goes out of the function, the variables stored on the stack are not thereafter available. We call that the variables die when the program control comes out of the functions. That means those variables will not be available for the program thereafter when the program control comes out of the function. However, when the variables of a function are declared as static variables, those variables are stored on data segment, and those variables are available up till the program terminates. So those variables die only when program terminates. How memory allocation works, that we are going to see in this slide. The compiler is the entity that allocates memory to the variables which are declared in the program. That allocation happens at compile time. So when we actually compile our code, compiler allocates memory to all the variables in that code. This kind of allocation is called a compile time allocation or a static allocation. Once the compile time allocation is over, or when the program is ready for execution, for running, the allocation made during compile time cannot be changed by any programmer. However, many programs need memory allocation during the runtime for the variables created in the program during runtime, and dynamic memory allocation is one way of creating variables dynamically during runtime of the program. Creation of a variable, in short, we can say that allocation of memory to a variable is creation of a variable. Dynamic memory allocation is also called runtime allocation. Dynamic memory, when there is dynamically allocated space for a variable on the data segment, that kind of allocation is called runtime allocation. There are many functions in C which are defined in a header file alloc.h, which we need to include in our program for runtime allocation of memory. There are three functions which we will be using in this program, in this presentation, which will explain and demonstrate the use of these three dynamic memory allocation methods or functions. Let us go for a program. In this program, we are using, or we are declaring, an array of pointer to strings, and we will be allocating memory to the data which is going, or the strings which are going to be used, and whose addresses will be stored in the array of pointer to strings. These are the two files which usual files. When we use strings, we include string.h, and a third file which we are using for the first time in our this series of programs or series of lectures is alloc.h, alloc.h. This header file contains all the information about the dynamic memory allocation functions available to C. Then we have declared a few variables, one string str, two int variables, and one pointer to a pointer of type char, char * list. List is a pointer to a pointer of a type char. We are now creating a array of string pointers named list, and for which we are going to allocate memory locations for the char pointer, array of pointers, in which we will be storing the addresses of strings which we are going to use in this program. Look at the function. list is equal to char star star calloc into the bracket 5 comma size of char star. This size of is also a function which takes out the memory requirement for the variable type of variable which is appearing in the bracket. This 5 is denotes that I want 5 locations for storing the pointers, 5 locations or 5 elements I am going to create for the array of pointers. As we discussed earlier, function calloc allocates 5 memory locations for char star. A char star is a pointer of type char, and any kind of pointer in C occupies 2 bytes in memory. So effectively there will be 5 into 2, 10 bytes which will be available to a pointer list. Char star, this calloc function, it returns void pointer after the memory has been allocated. It returns the address of the 0th element or 0th location of the memory allotted by it. It allots a block of memory, and the block size will be decided by number of locations the programmer wants to create and size of the required type of variable for which the programmer is opting to get a block of memory allocated using calloc function. And since the calloc function returns void pointer, we have to typecast it as per the program requirement and assign it. Here we are assigning it to a variable list. The list is created as a pointer to a pointer type char. So whatever is the pointer returned by calloc function will be typecasted to char star star. We can find out the address of the list, variable list, and we can also allot memory for every address stored. We can allocate memory to the address to the every element of list by using malloc functions, which we are shown here. List subscript I is equal to char star malloc 20. Here we are using calloc function. Here we are using malloc function. These two functions are used for allocation of memory dynamically in C programming. We can see the difference between these two functions. Calloc needs the size of variable type which we want the memory to be allocated for, and also the number of variables for which we are trying to allocate memory through calloc. In malloc function we can straight away allocate the number of bytes from the memory without bothering for the type of variables that will be stored in the list where we are in this case. So function malloc allocates 20 memory locations, returns void pointer which is typecasted to char star. Since we will be using the creation this array of pointer named list for storing the pointer to strings, so we are typecasting it to char star. After allocation of all the memories which we have done here, we can see the addresses of the blocks of memory allocated by calloc and malloc functions to our variables. To list, address of list is 2152. It will be having 10 bytes. The whole block will be of 10 bytes, starting address of which is 2152. Memory allocated to individual element of list is 5 addresses, having is allocated memory to block of memory allocated using malloc function will have addresses of 2166, 90, then 2214 and so on. These 5 are the addresses of the block of memory allocated by malloc function, and those addresses we are storing in the array of pointers to strings named list. We can see here we have not declared list as an array of pointers, we have just simply declared is as a pointer to a pointer, and to that pointer to a pointer what we are doing is we are storing and making it as a array of pointers of 2 strings. The strings addresses will start for we are doing it for 5 strings, so 5 starting block addresses of the strings which we intend to use in our program further will be stored as elements of list array. Then in the next step of our program we are going to assign strings to individual element, the address of which is already available, the memory for which is also available. We have to just fill in the strings which we want to do by using the strcpy function, string copy function, available in string.h file. We are to individual element of our pointer array list, we are assigning the values: detergent, toothpaste, soap, floor cleaner, hand wash. These 5 values I am allocating, I am assigning to the addresses stored in array of pointers to strings named list in our program, to individual elements of that array pointer. And then we find out the addresses of the strings again to ensure that the strings we are copying are getting assigned to the allotted or allocated memory blocks allocated by our malloc function. We are just checking whether the things are happening as per the requirement of our program logic. Now after this we will be going further with our program, and in this part of the program what I am going to do is I want to replace one of the items of the which we have assigned to array list by another item named differently from what we have given here. Now here by this printf statement what we are going to do is we are prompting user to enter item to be replaced from the given list of 5 strings, and when the user inputs the number of the item he want to replace from the list with a new one, that number in the list or the serial number in the list or the index of the list, index number in the list is assigned to a int variable j. Then we decrement j by 1 to match the input given by the user to the numbering of the elements of array of pointers called list. Since array indexing or the array elements numbering start from 0 to onwards, here we are asking user to input numbers 1 to 5. So if, say for explanation sake, user enters 4 as his choice, this 4 represents third element or element number 3, not third element, element number 3 of the list which we have created above, and hence this full cleaner item is appearing as 3 or at the number, index number or the element number 3 of the list. Then we ask user to input the next the new item which he want to put in. That item is assigned to a variable str. Then we use string copy function again, and the list subscript j is copied with new item which is assigned to str, and this printf statement displays the new list. It also displays the addresses again of the new list to ensure that the new item is copied into the same memory block from which we are removing one of the item. Now when I ran this program, I got this output: enter item to be replaced from the list. I entered my choice as 2, so that means I want to replace toothpaste with my new item. Then enter new item, it prompted me, I entered brush. So what I intend to do is toothpaste will be replaced by brush. The name of toothpaste or the string toothpaste will be replaced by a new string brush. Then I again found out by printf statement a display of the new list, modified list. So the brush appears in place of toothpaste in our list. However, all the memory locations which were available for our 5 items are remaining the same. The memory block starting with 2190, which was earlier was assigned with toothpaste, is now assigned with the string brush. Then this free function available in alloc.h file, it frees the memory allocated by calloc and malloc functions earlier. It is necessary to free the memory once the program is coming out and terminating, so that the memory block does not remain tied up with our program even though the program terminates. These free state functions will free the memory earlier allocated. Please note that the earlier in the memory which is allocated by program statically will be destroyed or will be deleted once the program comes out of function. But memory allocated specifically using dynamic memory allocation functions, we need specifically free those memory blocks by using the function free. So this is how pointer to strings, array of pointer to string works, and how we allocate dynamically the memory blocks to the variables during runtime using alloc.h files functions available in that file. So thanks for watching. Please subscribe to my free to view channel Programming in C with RSK, the ID of which is given below. Thank you very much.